Good morning, students. Let us study atomic mass. Every particle of matter has some amount of mass associated with it, whether small or large. Everything is made up of atoms. Mass of an atomic particle is called the atomic mass. It is best defined as 1/12 of the mass of a carbon 12 atom in its ground state. The mass of an atom can be accounted for by the sum of the mass of protons and neutrons, which is almost equal to the atomic mass. One atomic mass unit or AMU is equals to 1.66 multiply 10 raised to the power minus 24 gram. The atomic weight of an atom is the relative isotopic mass. Mass of molecules can be determined by adding the average atomic mass of each atom in the molecule. Next is molecular mass. Molecular mass of a substance is defined as the sum of the atomic masses of all the atoms present in a molecule of a substance. Therefore, the relative mass of a molecule is expressed as atomic mass unit, that is AMU. For example, let us calculate the molecular mass of water, H2O. We will find it out by following process. We know the atomic mass of hydrogen is 1 unified mass and that of oxygen is 16U, that means 16 unified mass. Molecular mass of water containing 2 hydrogen atoms and single oxygen atom. So let us see the calculation. Formula of water you know, H2O. It means there are 2 atoms of hydrogen and 1 atom of oxygen. Now what we do is 2 atoms of hydrogen are multiplied by its atomic mass, that is 1U, plus 1 atom of oxygen is multiplied by 16. So here it comes 18U. That means 18 unified mass. Now see in the periodic table, students, you will find atomic number and atomic mass both with the symbol of element. 3 elements are highlighted here. So you can see the first element is mentioned Ag. This is silver atom. Atomic number of silver atom is 47 and atomic mass, that is also known as molar mass when expressed in grams, is 107.9 grams. For carbon you can see atomic number is 6 and atomic mass, that is also referred as molar mass, equals to 12.01 gram. For sulfur, atomic number is 16 and the atomic mass, or say molar mass, is equals to 32.07 gram. Now let us study what are isobars. Isobar is that element which differs in the chemical property but has the same physical property. So we can say that isobars are those elements which have a different atomic number but the same mass number. Their chemical property is different because there is a difference in the number of electrons. It has the same atomic mass but different atomic number. Because an additional number of neutrons compensates the difference in the number of nucleons. The example of two isotopes and isobars is iron and nickel. Both have the same mass number, which is 58, whereas the atomic number of iron is 26 and the atomic number of nickel is 28. Now have a look on this image. These are the examples of isobar. Another example it is taken here, and these are argon, potassium and calcium. We are calling them isobars because their atomic masses are same. You can see, students, as a superscript 40, 40 and 40 each is written, it means their atomic masses are same. What is different? So, number of protons, that is atomic number, of argon is 18, potassium is 19 and calcium is 20. It means these are the examples of isobar. Now let us study what are isotopes. Isotopes are the atoms in which the number of neutrons differs and the number of protons is the same. From the above definition of atomic mass and the atomic number, we can conclude that isotopes are those elements having the same atomic number and different mass number. Let us know something about the isotopes of hydrogen. There are three isotopes of hydrogen, and these are protium, deuterium and tritium. All three of them have the same number of protons, but the number of neutrons differ. In protium, the number of neutrons is 0. In deuterium, it is 1, and in tritium, the number of neutrons is 2. Now see these three isotopes of hydrogen. You can see clearly the image what is made over here on the slide. That first one is hydrogen 1 with the mass number 1, because you can see in the nucleus only one proton is present, there is no neutron. See in the second pic, hydrogen 2, this is called deuterium. Mass number is 2 because there is one proton and one neutron in the nucleus. See hydrogen 3, tritium, mass number is 3, and in the nucleus you can see, children, 1 proton and 2 neutron, which makes its mass number 3. Now let us study isotopes versus isobars. What are the differences between these two? First one is, isotopes are different atomic structures of the same element. And in case of isobars, these are chemical elements having the same atomic mass. In isotopes, atomic numbers are equal to each other. And in isobars, atomic numbers are different from each other. In isotopes, atomic masses are different from each other. But in isobars, atomic masses are equal to each other. Now in isotopes, the same chemical element in different forms we observe. And in case of isobars, different chemical elements are observed. And the last difference I'll tell you, students, it is for isotope that physical properties are different from each other. But in isobars, physical properties are often similar. Okay, thank you, students.